I'm going to save this as these are the old ones. Oh, why am I in Python 1? I don't want to be in Python 1. Okay. So we're going back to, this is week 5, right? Okay. So remember, we're going to have to make up for the class that we missed, and that's going to be in week 7 on Monday, right? So data processing. There's a bunch of sources of data that we have. And the Singapore government has data.gov.sg. All right. So there's a bunch of data from about, so whatever the government is making public in forms of data, and there's a lot of publications that take advantage of this data. It's also published in a raw format. We can look, for instance, at society, right? And let's see, for instance, things that we would have. Singapore residents by gender, right? This can be an interesting thing to look at. And the interesting thing is that we can download from here, actually, a piece of raw data that we can load into Python and process ourselves. Okay? So, and I think I've loaded this a few times. I'm not quite sure why this is so large. Because there's a 1 there, so I'm sure I've been. All right, so this is an archive that just got downloaded, right? I've opened it automatically. And then there's a file that is called metadata, right? Metadata is in principle a description. It has some text that provides some sort of a description for the data that we find in there. Right, and then there's the actual data. Singapore residents by age group, ethnic group, and sex by end June. Not sure what end June means. Singapore residents by ethnic group and sex, and so this one also has age, so it's probably more interesting to look at. Normally these CSV files, they get open into Excel, which I have installed, and because of that, it always takes a while. But they're actually text files, so I don't want them to be open in Excel. I would want it to be open in other. So we can open it with the text editor that we use for our code, which I thought it was called VS Code. No, I'm not allowed to open with that one. I'm in applications, right? Or is it in the local applications? I don't have an open one. Okay, I do have a local applications. Visual Studio Code, this one. Oh, it opened a completely new one. No problem. All right, so let's look at this data, right? So you see, it's a text file. I can actually go and edit and write in it if I want to uh, mess with it. Um, but this is data that came in. Has extensions, not now. Right, so there's four columns here, right? So there's the year in which the data was taken. They say level 1, level 2. I have no idea what this means. And then there's a value. But what from looking at the values inside here, right? Level 1 is total residence, right? It's a keyword, but which we can use to segregate the data. So we have total residents, then we have total male residents, then we have total female residents, right? And then you see them also, so for total residents, we see them by age groups. So between 0 and 4 years old, right? This is the number. Between 5 and 9, this is the number, right? And so on and so forth. So essentially, you have some sort of a distribution of population, right? And this is a large file because just for the breakdown goes even further, right? So we go to total Malays, probably there's going to be total Chinese, total Indians, total other ethnic groups, right? And so on and so forth, right? So we can segregate. And only then, after 331 rows, we go to 1961. And we keep going till June, because that's what the file name says. The file says by June. So I'm guessing that 2018 which one? Right-hand side. Oh, this one is some sort. This one is a very compressed view of the entire file, right? Because if I want to move, I can move a lot faster, right? So most of the files are not that long. So you can put in this space, you can put essentially a view of the entire file. So then you say, oh yeah, I want to be somewhere probably maybe around the middle, and you can just take this and you go to the middle of the file, and hopefully you find what you want, right? So obviously you can move faster up and down. So there's 19,471 rows in this, right? The categories here are always the same, all right? I'm not sure how reliable data for 2018 is because it's until June. But it will be interesting to try to dig out some data. For instance, we could try to compute the average age, right? And see whether over time the population is getting older or younger, right? If the average age is older and older, right? The progression is older and older, then the population is aging, right? Otherwise, it's getting younger. There's many things that we can do, and this is actually one that is related to one of your homeworks, right? So because of that, I want to go a little bit through that and give you some preparation for homework number 4. Obviously, I'm not going to solve stuff that is already asked of you there. But yeah, so this is one interesting thing to find out. Is the population getting younger or getting older, right? So actually we know that it's getting older. That's a concern for a long time. But let's prove it with data. Let's dig our own, let's compute our own results and do that. So how do we do that? Well, this format of file, all right, is called comma-separated values, CSV. You see the CSV here, right? And it's because the records are 1 per row, and then the fields of every record are separated by commas. All right, Python has, so now we have two files, two windows, which is not ideal. Python has a library, and that library is actually given in the assignment, and I never know these things by heart, so I'm just going to go and load your assignment 4, yeah, which I think used to be assignment number 5 before. Where do I have the assignments? No? Okay, assignment 4. Oh, I didn't give you here the what you need to import. So let's find out then. So CSV reading and writing. We're going to have a CSV reader. Import CSV would open a CSV file. All right, let's just copy this. So we have to import this module called CSV. All right. And we're going to open our file whose name is copy path. Whose name is, all right, has a very long name, unfortunately. You know what I'm going to do? I'm going to say file name. All right, and then I'm going to say file name here. And we want to open in reading, not in writing. I don't think I need the new line. As CSV file, right? So this is going to be the name of the CSV of the file that we use. So we're going to, inside here, we're going to have a CSV reader. Let's go back to the reading example. CSV reader. So we're going to say reader equals CSV.reader. CSV file, delimiter, quote character. CSV file. And I think we don't need anything else. We're going to let everything else be default. All right. And now, one thing we would like to do is read the lines from the file and also write them to the output to convince ourselves that we are reading the right thing. All right. So for row in reader, and actually I'm not going to take all the 19,000 rows. I want just about 100. So I'm going to zip the reader with the range from 0 to 100, right? To make sure that we have only 100 elements. All right, and now row is a row of text. All right, so I'm going to, we know that we have 4 columns, right? So I'm going to say print row 0, row 1, row 2, just to have a very simple example. Row 3, right? So what we want to see is 100 lines that we have already seen open in the text. So notice that we haven't defined any procedure just yet, and we want to leave it this way. Everybody has followed? I'm going to go now and run the code. So, okay, here, cd python and week 5 monday.py. We get a tuple index out of range. Let's do row 0. Just, we don't know how many of them are. There should be 4 though. Oh, all right. If I do row 1, what is row 1? I see. All right, my mistake. So let's put an I here. And then we can go back to, so let's do it this way. I'm going to go back to this, and then I'm going to put an I. So what happens is that when we do this zip, all right, what does this zip do? We have 2 sequences. One is the reader, which is very long, and one is the range, which has only 100 elements. Those will be zipped together, meaning that the first element from one sequence and the first element from the second sequence are put in the pair, and the pair goes into the result. Then the second element from the first sequence and the second element from the second sequence are put in a pair, go in the result, right? So we have all the pairs, and this will stop at the shortest, right? The shortest sequence, which will be definitely this one, is going to dictate the length of the entire thing. That's why I did it, because I wanted only 100. I don't want to put 19,000 lines on my screen. It doesn't make any sense, right? But because I have zipped them, right, the result, whatever I have to be here, whatever I put here has to be a pair, right? So if I leave only the row automatically becomes a pair, right? Where the first element is an array and the second element is the index that comes from here, right? Now, if I make this explicitly a pair, then the row is going to be just the array. Clear? So now if we run, I'm going to get, okay, so notice that we're getting exactly the lines as they came from the file. Let me put them, maybe I can put them side by side. right? So you can see line by line that they're exactly the same, right? So what we have read here in Python is exactly the file. Now, all this data is available to us to process. So let's try to do that. I'm going to leave this here, right? We actually don't necessarily want to limit the size anymore, because it was just because we didn't want to print all that for our visualization. But we're not so interested in printing, right? We're more interested in performing some computation. So actually, we don't want a for loop, right? We're going to want some sort of a comprehension. All right. So let's select only those. So let's select only those. Let's look at total residence, right? So total residence. All right. And then how do we compute the average age? So I'm going to take all the total residents for 1960. Then I'm going to skip everything else. Right. Then I'm going to go to all the residents for 1961. Whatever that is, seems to be very far away. Right. Total residents again. Right. And how do we compute the average age? We sum everything up, right? But then we don't have specific ages. We have ranges here, right? So we don't know the distribution inside, right? But interestingly, all of them are ranges of exactly 4 years, which actually kind of helps. But we don't know the distribution inside. So we're going to take the average age in this interval as really the average. So 20 plus 24 divided by 2 is going to be 22, right? It's actually 5, right? 15 to 19 is actually 5. It's exactly. So we're going to take those ages, and then we're going to consider them average, and then we're going to weight those ages with the population for each range, right? So we want to do the following. First of all, we want to limit ourselves to total residents. How do we do that? All right, so we're going to have total residents, total resident ages is going to be, all right, so X for X in residence if X, and in this first column, we want the keyword to be total residence, right? So the first column would be X sub 1, right? And we want this to be equal to total residence. So this total resident ages is going to give us only total residents. And let's check that this is true. So we're going to do the same that we did before for a row and I in total resident ages, and we're going to zip them and range 0 to 100. What we want to do is print, and let's print the entire row. Okay, because we can do that. So are we going to see now only total residents? Reader. Okay, so trick that we learn, redirect the output. So I'm going to, again, quite a few of you are on Windows, right? So those who knew for you that are on Windows are probably not going to be able to do this. So bar less, and then you can actually inspect the entire output, go up and down. All right, so this is a trick that works in Unix, Mac OS included, right? So you can see that what we have selected here is total residence only. Yes? Uh-huh. I'm not sure whether this matters. This is misspelled. All right. And use tabs. No, 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 but what you're trying to do, you're trying to copy from one to the other. If you do Control D, in the name of the file from here. Oh, so this you need to quote. Then you have multiple brackets here. Extra bracket. Where? Here? You can do the same, just copy this. No problem. Pardon? I started as a coder actually. I started coding at I was about 12. Um, yeah, so I was one of those guys. Um, but I switched completely, right? So and I went to an engineering school, which so I studied computer engineering, which where I was from in those times it was more about hardware than software. And then I felt the need that something was missing because I liked mathematics in high school very much, and I started a PhD back home in Romania in theoretical computer science, right? So went completely the other way, and then came here to Singapore. I didn't like Romania was going through some trouble those times. I didn't, and the university was going through some troubles, and the quality of the research was not really that good. So after I passed my qualifiers there, came here and I started again. And also I did it in theoretical computer science. So I went completely the other way. I mean, thinking retrospectively, I think the mathematical approach is actually a lot more sane. Leads to, leads to much better software design as opposed. So it's very good to play with the bits and understand nitty gritty, and actually that helps a lot in many situations. Um, but yeah, if your focus is software development, being mathematical and being able to deal with abstraction, especially, it helps a lot. Okay. Anyway, if you just want.
I'm still not getting the file directory to work, even though I copied and pasted the .csv.
This one.
Yeah, well, different name, but yeah, that file. It keeps saying that.
Yeah, I'm actually quite surprised that it worked for me because there's the space here and. Usually I pay more attention. Python has evolved a lot, so like
Why did it was like I changed my file name to and I removed the spaces?
What happens if you use this, then you have to double the backslashes. I think in Python it actually doesn't make a difference whether it's backslash or slash. So you can try this. It's Windows. So the absolutely fantastic thing now with Windows is that you can install Ubuntu. You can install this Windows systems for Linux, which is almost painless. You can get it from the Microsoft Store, and then on top of that, there's some instructions. Relatively painless. It's not completely painless. You have to go and type some commands on your own, which if you haven't ever typed command line, might be a bit daunting. Then you can go and install Ubuntu, and you get an Ubuntu prompt, not the graphic environment of Ubuntu, but you get an Ubuntu prompt, and which exactly is this window, right? Where folders are separated by slashes and not backslashes, and everything. The world looks kind of sane. I could never understand why Microsoft went and used backslashes. So the world had been using slashes for folders for maybe 30 years at the time when Microsoft came with MS-DOS and invented and said, no, we shall use backslashes for folders. Creating, and I think even now, still, what does it say?
It got worse, I think. Because I have this, right? I have this user, and then it ends with zip, and then afterward I have the.
Wait, so many. I think you probably pasted twice.
Okay, but then I have the.
Oh, you know what Windows is doing? It is not really unpacking the archive. It is simulating the unpacking of the archive.
Well, I got different arrows, so that might work.
Yeah, residence is actually reader. We corrected it. I need to use these mistakes, right? So is this reader here? So you can say Control C here. See if it works now.
Yes.
Sorry, I cannot get
Into?
I cannot get the to print. So I'm using Python here because I can't figure out how to do it in any way. But it just says process completed.
Oh, so. idea where the cursor is with these colors. So what you need to do is put a backslash in front of your space. Or, actually, let's not do that. Let's do Python 3. Put a oh, why this? So you have to go here. Why did you? How did you even manage to put an ampersand in a formula? Can you rename that? So whenever you're in the command line, every special character has a special meaning. Therefore, it's not advisable to use special characters in the names. The only special character that you can use is underscore. Right? Some people use minus as well. Minus is relatively innocuous also. But everything else, like ampersand, hash, the exclamation point, percent, dollar, all of them have meaning. So as you type from the command prompt here, if you have file names that have those characters in them, the shell is going to try to interpret them differently. So you're going to run into trouble. So try not to use, caret also, don't use. All right, so we have the total residence. So the next step would be to try to separate the years, right? To try to separate on year boundaries. So instead of having an array of, so what you see, what we have is a sequence, which is actually kind of a list, right? Kind of an array, and each element inside is another array, right? So we have 2 levels. We want to go 3 levels, right? We want to have a big array inside. There's an array with all the 1960s, right? So all the 1960s that we have here, up to wherever they stop, they're in one array, but each element inside is another array with columns, right? So all the 1960s, actually I should have started here, right? All the 1960s, these ones, right? They all fit into another array. And then 1961s all fit into another array. So it turns out that there is a operation that does that for, that is predefined. So it's called group by. Python group by. And default list. No. Okay, in group by input key sort. This is too complicated to follow. No, I don't want pandas. Is this pandas as well? Iter tools. This is the one I want. Sorry. Group by. All right, make an iterate that returns consecutive keys and groups from an interval. The key is a function computing the value, blah, blah, blah. So we call it as an example. Is there an example? All right, so we have to use group by. We are going to import this module called itertools. So import CSV from itertools. Import group by. And you notice that it is already known. So what do we want to group by? We want to group by the first column, right? So ages by year is going to be, all right, group by and we have total resident ages, and we need a function that gives me what is the thing to group by. And I'm going to have lambda, right? It takes in a row from this collection, right? And it returns row 1. Sorry, 0, first column, right? So this should give me now three levels of arrays. So let's see that happens. I'm going to change this. Command C, Command V, and let's run it. And actually, 1960 to 2000, and actually we can get rid of this because it's going to be fewer than 100 elements in there, right? So let's see what we get. If we go here, all right, I'm going to run this again. And what do we have now? So notice we have the 1960 that we wanted, and here we have a sequence. But remember, this is a lazy sequence. All right? Remember the lazy sequence thing, that we don't see the elements unless we actually need them, right? So it doesn't tell us what's in there, but we can be confident. And actually, let's try to find out what's in there. Let's try to find out. And so instead of printing, we're saying for row. So for year, right, in total residence by year, print year. And then for row in year 1, right? So we have the year element, which has 1 year, the label of the year, and the other collection, right? So the collection is, if you look here, right? So this is a pair, this is a tuple. So this is year 0, sorry, this is year 0, and this is year 1. And we want to find out what's in there. So we say for row in year 1, print row, right? This is what we're going to do. And this actually is going to be probably more than 100. So we want to print about 10 elements, not more. 0 to 10, and we say row comma I, and we print the row. And let's see how this works. Too many values to unpack. Again? Yes, it has to be zipped. That's very true. Thank you. right? So you see 1960s, and then we have 10 records for 1960s, right? 1961, and then we have 10 records, right? So now we have 3 levels of arrays. We would like to turn these 3 levels of arrays into a dictionary, all right? So the dictionary would have a key, which should be the year. We don't want the year to appear so many times here, right? And we want then what we have the year pointing to be this 2-level array, right? It's an array of rows. So let's try to do that. In the meantime, for each of these, the first 2 columns become redundant, right? The 1960, I know it from the key, and the total residence is always total residence, so there's no point in keeping them around. I'm only interested in the last 2 columns, okay? So let's see how we do that. All right, so we have total resident ages by year. All right, and we're going to start with a dictionary. Let's call it D equals, and this will be an empty dictionary, right? And for year in total resident ages by year, right? So this gives us a collection. All right. I'm going to have that D year. And actually, we don't want the year to remain a string. Notice another thing. You know, you see the brackets, the quotes around 1961. That means the 1961 is a string, but it's only digits inside, right? So it makes sense to have it as a number. So I'm going to say that D, and I'm converting this into an int. All right. Is equal to. Okay, so now we want to add to this as a sequence, right? So we're going to make it first the empty sequence. D int year is going to be the empty sequence, all right? And then for row in, and actually D int year 0. All right, so remember, this is our year. This year that you see here, this is this guy, this entire guy. All right, and the actual year label is only year 0. And then everything here we take and add it into the collection corresponding to the dictionary, right? So for row in year 1, all right, what we want to do is D int let's do something numeric year is equal to year 0, right? So this is the year as a number. I'm going to use numeric year here. And there should be an int around this. All right. Numeric year, we start with an empty sequence, right? Year 1 is going to be the lazy iterator that contains all my rows. So numeric year, and we want to append row, I think. All right, so for every year, and then for every row corresponding to every year. And I don't want to append the entire row because we were just saying that the first two columns are useless, right? So I want to append from columns 2 to columns 4. First inclusive, the last one exclusive, right? So if we look at, right, this is one row. I'm only going to use this data. Okay, so let's see what we got. So now we have the dictionary, all right, and I'm going to say here for year and data in D. All right, so we print the year because we want to make sure that the year is there, and we want to for row in data and maybe we don't zip. We print the row. Let's see how this goes. The object is not iterable. Int object. What line was that? Line 15. Okay, I'm going to go out of my, I'm just going to say print D. This should work. Okay, so this is working fine. So you see we have 1960 and 1960 is very long. We can spot 1961. $1962 is here. Okay, so it's not that far. Right, so what do we see inside for 1960? As I go, oh, 1961 is here, right? So this is 1961. So this is 1960, what is highlighted. So what you see is tuples essentially, right? Pairs. So I have the 0 to 4 years, 29,700, 5 to 9 years, 250,000, right? So we have all the numbers that we need now, right? We can try to print it nicely. So let's give it another try. For K in keys D. All right, print K. And then for row in DK, print row. So this should print it more. Not keys D, D dot keys, I think. Okay, so now we can see it, right? So for 1960, right, we have all the data we need, right? Age group plus population. Then 1961, we have age group and population, right? So we made the data more amenable to what we want to finally compute, all right? And we still have this problem. We have this not available here that is kind of nasty. And the only thing we can do is actually just rule it out because we don't know what's there, right? We can just not take it into consideration. As you see later, right? We have this this population here, but it's not very clear again. 65 years and over, 75 years and over. We don't know what that means. Right? So does 65 years and over, is it the case that is the sum of all these? Right? It should, right? So this over is also data that we don't know how to interpret, so we're going to throw it away. Okay? So where is it the best to throw this data away? Where is it the best to throw this data away? Yeah. So actually it's here, right? So this is the easiest place to do it. So you can say one thing is that we want total residents, but we also want X, X4, X3, right, to not be equal to not available. So X3 not equal. Does Python have not equal? I think it doesn't. Oh, it does. Ha. X3 is not equal to not available, right? And we want another thing, right? We want that the age group, right? So this is column 3, right? Or column 2 actually, because we're counting from 0. We don't want to have this and over. Okay? So how do we check whether a string ends with something? Well, we have this there must be something here that starts with and ends with. There should be an ends with, right? So there's a function called ends with that will help us deal with that, right? So what we want is not X, what was that, 2, right? Dot ends with, and what was there? And over, right? And over. All right, so this line is too long. Let's break it up here. Right, so we're saying if X is total residence, right? But X1 is total residence, but X3 is not available, and it's not a case that X2 ends with and over. Okay, so now if I run this code again, this D that we're computing here should be the data that we want. Oh, and over is capitalized, so we should also do that. So, and over, otherwise it won't work. So notice now that there's no more not available, and there's no more, the and over is not there anymore, right? So this is completely data that we can use for our computation, right? So what are we going to do now? We're going to, for each year, we're going to compute we're going to compute the average age. We're going to parse this and compute the average age of this interval. And then we're going to multiply that age with this number, right? We're going to add everything up, right? We're going to add everything up. And we're going to divide by, the sum of all these numbers, right? The sum of all these numbers in this column. And that should give us the average age. Am I making sense? Yeah? All right. So, okay, so let's keep going. Right, so so K is actually the year, for year in d.keys. Right, keys are whatever I print here. Right, a dictionary is, remember, a mapping from a key to a value. So the key, so they're keys, right? So a key is like the year, and then a value is this entire sequence, right? And then another key is 2016, and then the value is this entire sequence, right? So then for each year, we want to compute the average, all right? So we're going to separate the columns, right? One is going to be the ages equals, and we're going to have we're going to have row of 0, right? For row in the year. Okay, so these are all the rows. And then we're going to have the counts, population counts, equal row 1 for row in the year, right? And now the entire population is going to be sum counts, right? Now age is a bit more difficult. You see, this is a string. I'm just going to take this string separately, and I'm going to take this string here. And how can I get the numbers 0 and 4 from the string? Well, one thing I can do is split, and split by space, right? And you see very quickly we get an array where the first number is number 0, but it still has a string, and the second number is the which element? 1, 2, 3, 4, right? So the first and the fourth element, that's what we want. So we can do split, all right, and we select as a pair those two numbers, and then what we want is the average. So we're going to add them up, divide by 2, right? So we're going to say average ages equals let's see if I can write a comprehension for this. I can, but it will be very inefficient. So let's actually say that average ages, we start with the empty sequence, and for age interval in ages, do age split is age interval dot split by space, and then we're going to say average ages dot append, and we're taking split 0 as an int plus int split 4, we were saying, right? And this entire thing divided by 2. Okay, I'm going to space it a little bit so that it's clearer that it's correct. Okay, seems correct. So now we are taking, instead of producing a comprehension, why is that? You see, because if I were in a comprehension, I could not define this variable, right? This is an operation that is a bit expensive, right? I don't want to do it twice, but I need this array twice, once here and once here. And if I were using a comprehension, I would actually write this entire expression twice and force two evaluations of the same thing unnecessarily. So this is a bit faster. We're writing code is a bit faster. So now this average ages is the average age of every interval, right? All right. So now we have the average ages, which is from 1960 to 2018. We have the counts, which are also from 1960 to 2018, right? We want to produce the weighted sum, right? So of ages. So weighted sum is going to be equal to, and how do we compute that? There's going to be the sum of a comprehension. And that comprehension is going to be x times y for does this work? In zip of average ages and counts. This might not work. I am conjecturing here. Right? And the average age that we want to compute, all right, and we want to print for, and then we have year is actually Python will add a space by itself, and we have weighted sum divided by sum of counts. Yes? And this is the result that we were after, provided that what I did there works. Line 26. Okay, this one is noise now. Let's remove it. So weighted sum. So this one, split 0, split 4. But when I went here, zero, 1, 2, 3, 4, right? So if I say split Seems fine. If I have 11 and 16, okay, try again. I haven't saved. Nine 22. Okay, let's print split here. See what happens. I think we need a bit more. Okay, so we have something that didn't work. So we have age interval. Let's print them both. Okay, so this one is shorter for some reason. Okay, here we should be able to use a regular expression. Okay, so sorry, this is a plus. I won't explain what this is. So we take it as magic for the time being. For some reason, it's splitting very, I don't know why it's splitting differently. Why is 10 to 14 years different? So if I take this string,
Is there a way to modify all the strings that are from 10 to 14 years in the data set?
no, it's simply a splitting thing, right? So, yeah, but it shouldn't matter. Or maybe it does matter in Python. And I'm Python split by regular by regex.
Like when I do split, like the spaces don't count. It's just 0, 1, 2, 3, like then dash 14 years. Like there's no space. So like 4 would be out of range.
Because the two spaces are only when we have single digits, right? Okay, let's do something very hacky. So if I say int abc dot, what happens? There's an error. Can I check whether if string is int? Okay, isDigit will do that for us. All right, so we're going to do upper limit is equal if is equal int of split. What was there? What was there? What was there? What was there? So it can be 4, it can be 3, it can be 2, right? It can be 2. So upper limit is int split 2 if split 2 dot is JIT, else split int 3. So we take whichever whichever first appears as a digit. If split 3 dot is digit, else int split 4. This should do it. Okay, let's not do the int right here. And then we go here and say int upper limit. I'm going to send it to you because we're already past the time. I'm sorry, this was unexpected. If this didn't happen, I would have just gotten there in time. I will send you the code and we finish it next time. We'll see it running next time. Cool. Thanks for coming. See you next time.